So we'll place the Culvert civil cell in this sample file. I'll have referenced an existing terrain and a corridor. You see, just reference the corridor and this geometry is inside the corridor file. And that's it. And in this file, I just have this line that is my culvert. I'll display its profile. So it's just a straight line with minimum slope. And we're good to go. So we have this first parameter for the civil cell. We need also the alignment of the road and the hinges for the slopes. But in fact, we need copies of them in the area of the civil cell. We don't need the whole corridor. In real life, the corridor may be really big, so we'll just duplicate the three elements we need in the few hundred meters next to the future culvert. And in order to do this, we'll just use a single offset partial, and we'll activate create 3D automatically. I'll take first the geometry, and yeah, I'll be generous here. So the alignment is done. I don't need now this alignment, and I can duplicate now the hinges at from the same point I've just created for the alignment. So the other side. Okay. So this is all I need. I can undisplay the graphics for the corridor, and we are good to go. So we'll launch the Place Civil Cell tool. So, and it's this culvert head wall. So first parameter is the culvert, then it's the main road alignment, and the left, and by left it's upstream. So in this case we are going in this way, so upstream is here and downstream is here. So then the geometry is recomputed locally to this project. And you see that at first, since part of the cell is built from a side slope computation, the drawing is kind of strange, but once you accept, so you don't have to use alternatives, you just accept, and then the cell is recomputed locally. Okay, so now we have the cell that is placed. In the plan view, we have these walls that indicates where the optimum position for the head wall is. So here we are not bad. We are not bad. And if we take a look at the 3D model, we see that we have the head walls that just popping out of the slope for the corridor. And to see through this culvert, now we need to go back in the corridor file, and we reference the file in which we place the culvert. We just have to refresh it. Usually I just have the sign here, but it's maybe because I'm recording. So now I do see I have the culvert that is referenced, and I used these terrain models as targets to compute the side slope of the corridor against. So locate corridor, no, define target aliasing, locate corridor. And now I have the reference terrain model, so the target ones for downstream and upstream, and after the existing terrain. And I don't want to target those. Those are to the ones that just display the walls. So I'll apply the computation, close, and I can see that the civil cell has been taken into account, but I see that I have some misses here, and this is due to the computational steps. And with a few case stations, it will be taken care of. So I'm good now. Need also one around there. Depending on the original steps, you might have to create those to force the computation of the corridor where you need to. Two more, and we are good to go. Okay, seems good now. So we are in the corridor file, and I can see now that the corridor indeed has been cut out with the target terrain models. I can remove the construction objects and take a look at the resulting model. So seems good. I'm in the corridor file. Now I'll go back in the civil cell file and same. I just have to update the reference to see the clipping from the culvert applied to the corridor. This is how you can model a culvert and automatically cut the slopes from the main road on top of it. A few words on the civil cell, how to manage the width, the heights, and so on, the angle for the wall. So these different settings first for the width. We have these two objects that are offsets from the initial culvert line, and if you select them, you shall see manipulators and at the middle. So you see that the default value is minus 1.7, and you have exactly the same at the other side. This one named CUR, which is 1.7. So this is for the width. For the height, we'll take a look at CUM for master. And if we open a profile model, the height is derived from this offset here. And you just have to update this value. Um, yep, some more settings. There's an offset between the exact head wall location and the location of the head wall because of the wall have a width. So this is managed by an object, a line with everything is on the construction level, and you'll find this CUD offset by default is 50 centimeters. So obviously you can change it the way you need, and you have the same at the end of the culvert. So obviously it will be the one there, CU offset U. Now for the side slope. So the side slopes by default are assuming a 50% side slope, and you can manage this um, by these two objects here and there. So they are 3D slopes, and you can act on their values here. So this is for the one here and the other one. Same story, you can change the slopes here. And I think that's it. I mentioned the width, the height, the offsets. Yes, the geometry for the wall. You see that, so this huge general model is for targeting the corridor to be sure to find the intersection. And so these are the head walls, and the bottom of the head walls by default, so it's this guy here, and it will go back to this location here and to the existing ground. And if you want to adjust this, obviously you can edit this profile and make it the way you want. So I'll just display the profile if you may want to change it. So um, it originates from the bottom of the head wall here. You see that it's this point is D CUG const L. It's this guy here that represents the bottom of the head wall. And this line is simply snapped to the end of the existing ground, so you can shape it and slope it the way you want, sure you need it. And the all four walls are done exactly the same way. So I hope you'll like it. I'll welcome feedback and hope that it solves some of your issues. And I forgot the best part. Once you've placed it, it's fully dynamic. That means that if you ever update the culvert, then the civil cell is recomputed. You can go back in your corridor file, you update the culvert file to update the clipping. Clipping well, file is updated, clipping is updated, and you can reload the correct file in your updated culvert with the updated clip from the corridor. And if we see this in 3D, you see that everything's nice. And here, well, everything's not nice because well, the location is correct, but you see that the head wall is after the markers, so the wall is not high enough. And because the culvert is not long enough, so that means that I have to make it a little longer. Maybe here will be good. Better. One last update. And we're good. So very easy to adjust the culvert location.